Hey guys, so we are on to our third conic section, which is parabolas. Okay, so we've done ellipses and hyperbolas. Now number three is parabolas. So you guys should be familiar with parabolas. You definitely worked with parabolas in Algebra 1 and last year in Algebra 2. Okay, but you'll see that the way that we look at parabolas is a little bit different in pre-calc. Okay, so looking at this diagram here on the left, you should recognize the word vertex. Okay, and you should recognize axis of symmetry, okay, which is this axis that goes through the vertex, in this case vertically. Okay, those are not new. You guys definitely talked about those in the past. Okay, what is new is this term directrix, okay, and also focus. Okay, so focus is the singular of the word foci that we've dealt with a lot with ellipses and hyperbolas. So you'll see that there's also a focus for parabolas, but there's only one. Okay, for ellipses and hyperbola, it was foci, meaning plural. There's just one here. Okay, and we'll go back to that diagram in a second. Right now, the definition, a parabola is a set of all the points x, y in a plane that are equidistant, okay, so the same distance from a fixed point, which is called a focus, and a fixed line, which is called a directrix. Okay, so you should take a second right now, pause your video, and make sure that you fill in all of those notes for this definition. Okay, so a parabola is a set of points equidistant from a fixed point called a focus and a fixed line called a directrix. Okay, so going back to this diagram now, using that definition. So every point on the parabola, so if I take any point, it could be the vertex, it could be some random point over here on the left, it could be some random point on the right. If I measure the distance from that point to the focus and from that point to this line down here, this dashed line called the directrix, that distance will be the exact same. Okay, so for the vertex, it's kind of easy to see because it's just up and then down. Okay, but let's say we take this random point on the left. If I measure the distance to P, which is the focus here, and I take the distance straight down to that directrix, those distances will be the same. All right, or you'll see here in blue, this point on the right, D1, meaning the distance to the focus, and D1, the distance to the directrix, are the same. Okay, so this definition should be pretty different than what you're used to from parabolas in Algebra 2. Okay, but any point is the same distance from that point to that line. Okay, so pause now if you've missed any of these notes before we move on to the next page. All right, guys, so we'll see there are 4 standard form equations for a parabola. Okay, and basically one is a parabola facing up, down, left, and right. Okay, so what's a little different from Algebra 2? First off, the equation should look very different to you. The standard form equation in pre-calc that we use for a parabola is different than that you used last year in Algebra 2. And secondly, we are now going to look at sideways parabolas or horizontal parabolas that open right and open left, whereas in Algebra 1, Algebra 2, you guys only dealt with parabolas that open up and down. All right, so this first set of 4 is if the vertex of the parabola at the origin, which we know is 0. Okay, and then at the bottom, the same 4 equations. There's still only 4 equations in standard form, where you have HK, where the center is not the origin. All right, so for the most part, we'll be dealing with these 4 down here. Okay, but I guess it is good to see if H comma K is 0, this is what it would look like. Okay, so I'm going to draw next to each one which type of parabola that would be. So the first one there, x squared equals 4py, would be an upward facing parabola. X squared equals negative 4py faces down. Okay, and on the right hand side, y squared equals 4px opens to the right, and y squared equals negative 4px opens to the left. Okay, so take a second if you haven't filled those in, pause your video now. Okay, and at the bottom, it's the same 4, just these are using any vertex, where the vertex doesn't necessarily have to be at the origin. So we're more concerned with these 4 standard form equations at the bottom, because most times h comma k won't be 0, won't be the origin. Okay, so again, the first one opens up. On the bottom here, opens down, open to the right, and open to the left. All right, guys, so h comma k is the vertex of your parabola. When we get to class tomorrow, we're going to talk about graphing these and what to do with this letter P. Okay, so you'll see the equation has 4P. So each one of these problems, you're going to take this coefficient, divide by 4 to get P. And we're going to talk about in class tomorrow what you do with that P value. Basically, that P value helps you get the focus and the directrix. All right, but the thing I want to point out to you guys today, okay, that you should notice only one of the variables is squared, either x or y. So on the left, x is squared, y is not. Okay, and then on the right, y is squared, x is not. Okay, and then also notice some of them have a negative in front of that 4p, the others do not. Okay, so basically the way that you determine does the parabola open up, down, left, or right are 2 things. Which variable is squared, and then on the other side is the coefficient positive or negative. Okay, so basically is that p value positive or negative? So x squared and then positive p means it opens up. X squared negative p would be down. When y is squared and we have a positive p value, it opens to the right. And when y is squared with a negative p value, it opens to the left. Okay, so basically when x is squared, not y, like these 2 on the left, it either opens up or down. You look at the coefficient on the other side. When it's negative, that tells you down. When y is squared, not x, it's either going to open right or left. A positive p means right, negative p means left. All right, guys, so that's it for today. Just take down, make sure you got down these notes. And starting tomorrow, we're going to go over in depth how to graph these, how to use this equation to graph a parabola. Have a great day.